Hello, dear students. This is the last session of unit number 1, that is the basic of software testing and testing method. Our today's topic is white box testing part 2. In last session, we have seen what is white box testing. In this session, we are going to learn that white box testing approaches. So basically there are two approaches, that is static white box testing and dynamic white box testing. You are already aware about the static and already aware about the term static and dynamic. So static white box testing means you need to review the code without you need to review the code. You do not need to execute an application. In dynamic white box testing, you need to check an application by executing it. So you are checking the code by executing the application. So in static white box testing, you need to perform a formal technical review. So there are three types through which you can perform a formal technical review. So first one is a peer review, or we can say a buddy review. Second one is a walkthrough, and third one is a inspection. In dynamic white box testing, you can perform a dynamic white box testing by four ways: by performing a line coverage or statement coverage, or path coverage or branch coverage. Then next one is a condition coverage, and last one is a code complexity, or we can say a cyclomatic complexity of the particular code. So we'll start with the static white box testing. So static white box testing means you do the static that the term static means you not there is no need to execute an application. You just need to check the application by only reviewing it. So white box testing means you need to check the code. Okay, so how will perform the static white box testing? The static white box testing is an process of carefully and methodologically reviewing the software design, architecture, or code for bugs without executing it. It's sometimes referred as the structural analysis. The static white box testing is performed using formal technical review. So you need to perform a formal technical review. So formal technical review can be done by using three ways. That is peer review, or we can say buddy review. Second one is a walkthrough, or the third one is a inspection. So what is a formal review? So formal technical review is a software quality control activity performed by the software engineers. The objective of formal technical review are it is useful to uncover error in logic, functions, and implementation for any representation of the software. The purpose of formal technical review is to verify that the software meets the specified requirements. Basically, there are four phases of formal technical review. So means you are performing four activities. First one is prepare. So before conducting formal technical review, so I am just give you a basic idea of a formal technical review. This is an activity where the expert of the industry will form a committee to review your application or piece of code to find more and more bugs from it. And this process is important because it will improve your quality of application. So this is a formal method. So you need to schedule the meeting, and before in schedule means while you're that before the day of your particular review, you need to provide some documentations or your piece of code to that particular team, so they can review it and prepare their questionnaire. And at the time of review, you need to explain your application, and they will ask your question, or you need to you will get their feedback or their suggestions. So according to you, revise your application and improve the quality of application. Okay, so there are four activities, or we can say phases of formal technical review. You need to prepare for the review. Actual review is conducted. After review, you need to record what kind of suggestions you will get from the technical experts, and after recording you need to prepare a report. You need to prepare a report, what kind of suggestions they have given and what kind of actions you have taken after the review. So you need to report it. Okay, so there are three technique. First we'll see the roles and responsibilities of formal, which is performed in formal technical review. So there are total five roles. First one is author, or we can say a reader. The author is whole and soul of an application. Means he actually builds an application, and he will read application in front of the committee. Okay, line by line he will read the application in front of the committee. Okay, second one is scribe, or we can say recorder, which is actually make a documentation at the time of review, what suggestions you will get from the committee or what feedback you will get from the committee. So it will going to be recorded by the recorder. Next one is a reviewer, or we can say inspector. So anybody from the committee can play a role of a reviewer or inspector. They will review your code, and they will ask question about the code, or about the application, or any functionality of that particular code. Next one is a moderator. He is a what we can say, he is a review leader. So he will lead the review process. The main aim of moderator is that he will actually control the review if the review process is going out of track. So the moderator is responsible to make process on track. He is actually the he is actually playing an important role in the review process. Next is a manager. A manager is involved in the review, as he or she decided on the execution of review, allocates time in project schedule, and determine whether the review process objectives have met or not. So they are just examine that the objective of that particular schedules have been met or not. Okay, the three ways the three ways of formal technical review. The first one is the peer review or buddy review. Here the peer review, we can say it is informal. Why informal? In peer review, your colleague will test your application in meanwhile, and he or she will give you a suggestion, and according to it you will improve your application. So it is just informal, but it's a part of FTR. So we can say it is a formal review. The whole artifacts of review by co-worker and or interested party, largely unstructured and without formal assignment of roles. So here is no need of any schedule, or here we can say there is no need of providing the information or some documentation before the review, or there is no need to assign any role in peer review. You need to show your application to your buddy itself. So there is no need of such formalities in this review. So no formal review record is prepared, and review is conducted within the limited time scales. Okay, next one is walkthrough. This is the actual formal technical review. In this process, the author, that is the reader, we can say reader, the actual who built an application, uh, means this process is conducted by the author of the document under review, who takes the participant through the document and his or her thought process to gather the feedback. So he will explain the application, or we can say he explain line of code one by one, and the thought behind it, this process is to get the feedback from that committee. The content of the document is explained step by step by the author to reach the consensus on changes or to gather the information. The participants are selected from the different department and backgrounds. If the audience represent a broad section of skills and disciplines, it can give the assurance that no major defects are missed in the walkthrough. So the idea behind is to discover more and more bugs, and we need to discover the that kind of bug which is having a higher priority or higher severity. So it is very much important to have a formal technical review. Next is the inspection. This is also like a walkthrough, but in walkthrough there are only four roles, like author means reader, the second one is a recorder, third one is a reviewer, and fourth one is a manager. But in inspection process, or all five roles are involved in this process, like reader, recorder, then reviewer, or we can say inspector, then next one is a moderator, and last one is a manager. So here the uh, in a walkthrough process, the author is whole and soul, or we can say host of that particular review. He will read the code line by line, and he will give the answers to the committee. But in this process, in inspection, the moderator is playing the role of host. He will read code line by line, and his aim is that the communication is not going out of the track, so he is whole and soul responsible for it. The inspection is the most formal review type. It is usually led by the trained moderator, certainly not by the author. The document under inspection is prepared and checked thoroughly by their viewers before the meeting, comparing the work product with its sources and other reference documents, and using rules and checklists. In the inspection meeting, the defects found are logged. So you need to log the defects, and according to the defect list, you need to make changes in your application. So it is also a important part of formal technical review. Next is the next testing approach of white box testing is dynamic white box testing. So why it is called as dynamic white box testing? The dynamic white box testing use the information you gain from seeing what the code does and how it works to determine what to test and what not to test, and how to approach the testing. Another name commonly used for dynamic white box testing is structural testing, because you can see and use the underlying structure of the code to design and run your test. Means you are executing code, and check it. Okay, so there are four ways. So the first one is a line coverage and statement coverage, second one is branch coverage and path coverage, third one is a condition coverage, fourth one is a code complexity or cyclomatic complexity. The main aim is to test your code by executing an application. Okay, so first one is line and statement coverage. Here you need to check each and every statement of your lines of code. You can find out the coverage, statement coverage, by using this formula: the number of executed statements. So how many how many statements you have executed upon total number of statements into 100. So you will get the percentage of statement coverage, how much statement coverage you have done uh, in dynamic white box testing. So you will get it. So statement coverage is the method of validating whether each and every line of the code is executed at least once. So you will get idea while you are taking the statement coverage. Next is a branch or path coverage. In branch, we validate whether each branch is executed at least once. Means if in case of the if statement, there will be a two test condition, one to validate the true branch and other is to validate the false branch. The branch coverage is a testing method which is when executed ensure that each and every branch from each decision point is executed. So you need to make sure that each and every branch must be tested. So how you will get the exact coverage result? So there is a formula: branch coverage is equal to number of executed branches upon total number of branches in your application into 100. So you will get exact coverage record. So according to it, you can improve your process. uh, the idea behind branch coverage is you need to visit each and every branch at least once. Okay, so here is the example of branch coverage. This is a code. First step is if a is equals to 50, then if it is true, okay, then check if b is greater than c. If b is greater than c, then go to third step. The third step is third step is a is equal to b. If b is not greater than c, then go to fourth stage, that is a is equal to c. After that you are come to the fifth step, that is end if. Then next is sixth step, that is end if, and last one is print a. So here there are possible three paths. In first, a is equals to 50. If a is not equal to 50, then it will directly jump to the end if, that is steps 1, step is sixth, and it will directly print the value of a. So this is the third path. Okay, so there are three paths. First path 1 is first, second, third, fifth, sixth and seventh node. Path 2 is first, second, fourth, fifth, sixth, seventh node, and path third is first, sixth, seventh node. So you need to test all the possible branches or possible conditions of the particular piece of code at least once. Okay, so in this example we can see there are few conditional statements that is executed depending on the conditions. Basically here are three paths or condition that needs to be tested to get the output. Next is condition coverage. In this coverage expression, with logical operands are only considered. For example, if an expression has a boolean operation like AND or XOR, which indicates the total possibilities, conditional coverage offer better sensitivity to the control flow than decision coverage. So you need to check more than one condition in this condition coverage. So the formula of condition coverage is number of executed operands upon total number of operands into 100. So you will get the exact condition coverage of your application. So example of condition coverage, here are two conditions, that x is less than y and second condition is a is greater than b. So within these two condition we are using the logical operator, that is AND. So at least one condition from this two condition must be satisfied, then only the below code is going to be executed, right? So there are for the above expression there are four possible combination, that is true means first condition is true, second condition is true, second condition is false, first condition is also false, then first condition is true, then second one is false, then first condition is false, then second condition is true. So TT, FF, TF and FT. So I am taking the input so here the input value for x is 3, y is 4, a is 3 and b is 4. So is condition is true. So first condition is so x means x value is 3 and y value is 4. So first condition is going to be true because x is less than y. And second condition, a is equals to 3 and b is equals to 4, and condition is what, a is greater than b. So here the condition is going to be false. So actual condition coverage is 1 of 4th, means out of 4 condition your first only one condition is true. That's why your condition coverage is 25% only. Okay, next is code or cyclomatic complexity. So cyclomatic complexity is the source code complexity measurement that is being correlated to the number of coding errors. It is calculated by developing a control flow graph of the code that measures the number of linearly independent path through a program module. It can be represented using below formula. Uh, from this statement, I think so it will be not it will not give you a clear idea, but after viewing the example you will get the clear idea what is the code complexity, or we can say cyclomatic complexity. The for that we need to go through this formula. The cyclomatic complexity is e minus n plus 2 into p. So what is the term e, n and p? So e is the number of edges in the flow graph. Means you need to make a flow graph of that particular code, or we can say the errors occurs in that particular code. So according to it we can make a flow graph of that particular lines of code, and according to it we can find the cyclomatic complexity of it. So e is the number of edges in the flow graph, n is the number of nodes in the flow graph, p is the number of nodes that have a exit point. So p is the number of node that have exit point. Okay, so e is the edges, n is the node. So we'll take this example. Here the code is, if a is equal to 10, then what you need to do, again you need to check if b is greater than c. Then you what you are going to do, a is equals to b, else you are doing a is equals to c. Then end if, then also end if means this is also similar to the previous example which we have seen in the branch coverage. Here we will print the statement, print the value of a, b and c. So for this code, this is the flow chart. So there how many nodes are present in this flow chart? There are total 7 nodes are present in this particular flow chart. You have seen see this, a is equal to 10, b is greater than c, a is equals to c, a is equals to b, end if, and print abc. So there are total 7 nodes are there, and to connect these nodes you need 8 edges. So calculate the arrows, or we can say calculate the path to connected this particular nodes. So there are total 8 nodes are 8 edges are present to connect these nodes. Okay, so the cyclomatic complexity, cyclomatic complexity we need to calculate. Here the node which is having the exit point is only a one, that is print abc. So this is only the exit node. So p is equal to 1, right? So the cyclomatic complexity of the particular code is 8 minus 7. 8 is the number of edges, 7 is the number of nodes. Okay, 2 is a constant number, and 1 is the node which is having or we can say node which have a exit point. So there is only a single node. Okay, So the total cyclomatic complexity of your piece of code is 3. So I think so this would be a clear to you how to calculate the cyclomatic complexity of an application. Here your first unit is going to be complete. Thank you.